Right, guys. So we're going to switch gears now. I'm going to talk about the work that we're doing to advance programmability on Cisco iOS XR, which is the lead operating system that we have that our products in the SP1 use. So in the first presentation.
Okay, SP1?
Yes, in the backbone.
What does the SP1 mean? We don't work for Cisco. We don't know all your acronyms.
SP1.
No, the backbone, the interconnection of data centers.
SD1.
Okay? Service provider.
WAN.
WAN, yeah. Sorry. Let me spell that out. SP stands for service provider, and WAN, I'm sure probably everybody's familiar with the term. All right. So programmability and I would say software automation is disrupting many industries, and obviously that getting reflected in networks throughout the world. It not only applies to data centers, but also applies to service providers and backbones in general. And the motivation, a big chunk of the motivation that we see of why our customers are demanding higher programmability is the need for speed and scale. Okay, just being able to keep pace with the growth that they're experiencing. But one key aspect actually is rapid innovation for them. And we're going to see how some of the recent enhancements that we're introducing in iOS XR allows them to achieve just that. When we look at device programmability in iOS XR devices, we look at two different types or two different approaches to do automation and software programmability on the device. One of them that we've had for quite some time, I'd say probably we've been working the last 2-3 years, is what we call model-driven manageability. So basically doing automation of the device, going through the management plane, using netconf, gRPC, and some other mechanisms. We're going to see that there's right now an ongoing transformation of going from old management protocols, syslog, CLI, SNMP, to a new infrastructure, and we're going to see what's special about that. I'm going to focus the first part of the presentation very briefly on the manageability aspects, and then actually we'll cover the second part, which is what we call the service layer APIs, that is going to give the customer, the user, direct access into the infrastructure of the device. It's a higher performance approach to automation and programmability on the device, in which you get to interact directly or more closely to the infrastructure of the device, and you achieve higher performance and you achieve higher control on the device. Okay. For now, let me just cover very quickly the manageability aspects. And as I said, this is the new infrastructure that is going to be replacing a big chunk of the protocols that historically have been used to manage networking devices. Incoming call from Los Gatos.
Fantastic.
Awesome. All right. So what is special about this new framework of manageability?
They really want to be part of
Los Gatos really wants to join. All right. So one of the key principles of this new framework is that all the manageability is based on data models. Okay? And we're going to see later why that is important. So the basic infrastructure, if you want, of the new manageability of the device is entirely based on data models, on Yang as the language that is used for those data models. And we see that on top of that, we have different choices of protocol encoding and transport for a client to interact with the device through the management plane. Okay, and I'm going to in the next slide I'm going to give you some details on two particular areas. I'm going to focus on first on the benefits, and then I'm going to touch on the APIs that make it easy, because at the end of the day is, okay, if you give me all this programmability functionality, how easy it is for a traditional network engineer, or how easy it is for a software developer to adopt this. So we're going to see some aspects of the API or the SDK that we provide. And also I'm going to give you some additional details on new work that we've done in the models. But before I touch on those two, let me talk about why we think that framework it's a special, or what are the unique characteristics that framework has. The first one is that it's entirely based on data models. Okay? Data models basically define all the configuration, operational data or counters that you can retrieve from the device, also specify any commands that you can remotely execute on the device. Okay? These data models have a very well-defined syntax and very well-defined semantics. So that makes it computer-friendly automatically, makes it friendly to tool chains. Okay? So it facilitates automatically the automation of the manageability of the device. The other key principle that we applied was to make sure that we provide customers different choices in terms of data models. You're going to see, I don't know, how many people here are familiar with Yang and data models as it comes to manageability of the devices? Okay? So not much, but again, the key principle is that data model has a specification. For instance, a data model defines how you can configure an interface or defines how you can configure a protocol, right? It's a formal definition, if you want, of MIPS and CLI all combined in a single syntax. That would be one way of seeing it.
So do we need to know Yang to work with this?
That's an excellent question. Do we need to know Yang? What we try to do, and that's going to become more obvious when I talk about the APIs, that we try to abstract as much as possible, because the big challenge that we see is that when people try to adopt, the poor developer or the network engineer saying, here's a pack of 500 pages of Yang documents for you to read. And that becomes, the barrier of entry becomes too big. And we try to abstract a lot of those details, yes. So with respect to models, we provide support for different ecosystems of models. So we have our own native models that will give you entire access to the device. But we also have what we call open models, so cross-vendor support. So you can also manage the device in a cross-vendor fashion. We decouple the models from transport protocol and encoding. So what does that mean? And we also give you choices in terms of transport protocol and encoding. Different customers have different tool chains. Okay, so let's say I'm going to configure a device. I may want to send that configuration data as JSON. I may want to send it as an XML, or potentially I want to use even a different format. Okay, different vendors have different tools, different skill sets. They have preference. Hey, I like to connect my box. I'm completely fine using SSH. Some other ones prefer more of a web-style interface, use HTTP to interface with the device. So we make sure that we give customers choice on how they interact with the device and still be able to use the same data models. Okay? The next key characteristic of that framework is that we put this layer of APIs at the top, and we gave it customers for free as an SDK, so they can easily start automating without having to become an expert in Yang, without having to deal with all the complexity of multiple transport, multiple protocols, and multiple encodings. And last but not least, we are striking a balance between open source and standards-based. There's a lot of debate in the industry whether standards are dead or not, and whether everything should be open source. I think at the end of the day, you just have to be pragmatic about it and just make sure that it addresses customer requirements. So whenever we see standard-based technology that makes sense, for instance, Yang is a data modeling language, we're using it. We offer, for instance, Google RPCs as one of the protocols and / transports. That's open source, so we are equally adopting it. So it's a very pragmatic approach. So I said I was going to touch very quickly on two areas where we've done a fair amount of work since we introduced the framework. The framework, we kind of did the initial announcement. I think it was December 2015, if I'm not wrong. And we've kept doing a lot of work. So one of the key aspects is that we kept the pace with the introduction of data models. As I said before, there are data models that are open, so are vendor neutral, and we have what we call the native models that are XR specific and give you more access to the entire device. We have assembled close to 375 data models. So the device ships with this. You can, again, if you're not familiar with data models in Yang, you can almost think as somewhat equivalent to MIPS, right? It's just that now the device ships and the device itself has those models, and you can actually even programmatically retrieve those models from the device. Okay. So let's zoom in specifically on the OpenConfig, because there's a lot of interest in the industry about OpenConfig. It's a consortium of operators that got together and they defined their own data models that are cross-vendor. Okay? The working group has kept a really good pace of developing new data models. So this is the list. It's a pretty comprehensive list of what we have implemented. I think I feel very comfortable saying that that is the leading implementation in the industry. I don't think any other vendor has this level of support. We work very closely with them in terms of implementation. And we have all the way from BGP to routing, routing policy.
I'm at a loss here.
Yes, tell me.
So VLAN, there's a VLAN data model. What does that let me define? What does it let me do? You know, we're very abstract, and I need to get down to...
So the VLAN data model will tell you what kind of things you configure on a VLAN. It will also tell you, in the case of OpenConfig, will tell you what kind of counters are available for VLANs. So let's take the example for an interface. The interface model will tell me that interfaces have a name, that a name is a string, that string has a specific format. It's not a free form. I cannot say the name of my interface is hello world. My interface probably has to be called gigabit something, or it has to be called Ethernet, or it has to be, the model will specify all that. Will specify that not only the interface has a name, and that name has some notation, it will also tell you that interfaces have a description, and that description, yes, is a string that cannot be longer than 256 characters. It will tell you that the interface is an empty.
Yeah, you're giving me a lot of detail.
Yes.
And I don't need detail. I need what is the handle on this? What do I use it for?
So if you think, Yang is generic, and you can use, so the piece is that, like MIPS, you know, back in when we had to go get MIPS from HPE for compact, from compact whatever, there has to be something that created the taxonomy for a server and the components of the server.
I get that. We're deep in the details of what's going on, and I haven't got why. I haven't got, what it is that having all of these data models does for me.
Because that data model has a very well-defined syntax and semantic.
I understand what the data model is.
Yes.
I don't understand what the use of the data model is.
Because you want to automate the configuration of the device, and because you want to automate the monitoring of your device. So instead of using CLI to configure your device, you don't want to write software that interacts with the device via CLI. And
no, I want to write software that interacts with some API that gives me.
So these data models are the formal specification on which the APIs are generated.
So one of the points to understand with the requirement for models is that APIs aren't contracts, right? Usually the way, if I provide an API on top of a service that I'm creating, I will give you documentation to go with it, right? So as a developer, you're going to look at the documentation, figure out what the APIs are, and then work with them. Now, one of the basis for model-driven API architectures is that the device has a certain base model out of which the APIs are created, which basically means that as a programmer, I can actually query the box for its capabilities. I can understand what the APIs can do during the programming exercise rather than having to go through documentation one by one. And most of the tools we look at actually do that. So model-driven API architectures is pretty much the way most of the newer architectures are being designed towards. And you'll see that even with gRPC style architectures, for example. So APIs with documentation is in a way slightly passé. You want to be able to create models that define versioned contracts of what your API is supposed to do, and your software should be able to glean that and then work with those APIs.
So in theory, if I have the model, I can create an API, across several sets of APIs, but they're consistent because I'm using the same model.
Exactly. And further, once you've created a model, you're able to become more or less language agnostic, and we'll get to that in a bit, because I don't want to give you a Python API only. If you're a Golang developer, I should be able to create Go bindings for you, right? So we'll sort of go into more details around how we're looking at model-driven APIs that way.
So the model not only allows you to generate the API, but also automatically generate the documentation for that API. It allows you to generate bindings for different languages. So it becomes your kind of language agnostic way of defining the capabilities of the device. Does that makes it more clear for you? Or?
Not really.
Okay, so maybe at the end we can have a side conversation and we can have a more detailed conversation on it. Okay, so as I was saying, we have a pretty comprehensive, I think we accumulated 20 models that we've implemented so far. We're still actively, or we're actively deploying, implementing new ones as they become available for the OpenConfig working group. This OpenConfig was created, I think, like 2.5 years, and they're keeping a really good pace of delivering models. But you see, for instance, ISIS, OSPF, there's some key ones that are still missing here. And you're going to see more and more coming from their organization and implementations coming from our side. Okay. So let me talk now about the APIs, because one of the challenges, I had the question before, do I need to become an expert in Yang? Do I need to become an expert on these data models? The big challenge that we see initially is that if someone is trying to automate configuration on the device or programmatically retrieve operational data from the device, suddenly they need to become masters in Yang. Suddenly they may need to become masters on Netcom, being one of the protocols that allows you to interact with that. So we try to, what we focus on is how can we abstract all those details, allow someone to automate configuration, to automate maybe the retrieval or the streaming of operational data without having to become a programming expert to manipulate XML directly, or JSON, or Netconf as a protocol, or Yang as a language. So what we did, we created the Yang development kit, and you have here the URL. We open sourced it, I think, March last year. We have a really rapid development. We have 12 releases in pretty much 18 months. And what this does, it basically creates these packages in both Python and C++ today, and we're working on providing additional languages in which you can create configuration objects if you want based on the data models. Okay, so as a programmer, I can instantiate an interface object, and that interface object already has all the fields that are defined by the data model, and I just plug in the data that I want. Okay, so the SDK does much more than just defining those classes who can instantiate those objects. One of the key things that it does is that if I'm trying to build a client to, for instance, change configuration on the device, when I create those objects, the SDK automatically is going to do the validation of my data. If I'm doing some automation of the configuration, for instance, of an interface, and in my automation software I made a mistake, an MTU, I assign a string, for instance, the model indicates that MTU has to be an integer. So my SDK automatically, my client automatically will throw an exception. It will tell me your automation code has a mistake. You're trying to send an invalid configuration to the device. So it basically allows you to implement very clever, very intelligent clients that already did a fair amount of validation of the data. One of the key characteristics also, as I mentioned before, we're multi-language, so we have Python and C++. We're actually actively working on a third language now, but we still haven't released that. And one of the key milestones that we had was the release that we produced in early August, the 0.60, because on that one we actually rewrote the entire infrastructure of the SDK. Before it was based in Python, now we rewrote it, so it's a shared library, libyDK, and that allows us to create these wrappers in different languages in a much easier way. But not only that, it introduces even better validation of the data, because we actually, as Akshay was mentioning before, when I write my client automatically, when it connects to the box, it retrieves the model and is able to verify my configuration on my client against exactly what the device supports. Because the device, I remember, is shipped with the models, and the models describe what that particular device is capable of.
So I asked if we would need to know Yang before. And here's my reasoning behind it, right? Like, I get this whole model-based method of things, right? But you made the comment, if I'm a programmer and I want to instantiate an interface object and have all these values, well, I guess it's not really if I'm a programmer, it's if I'm somebody who understands what that means in terms of networking and I program.
Yes.
Right?
So we track two profiles or two personas for this. You're going to have the network engineer that suddenly has to learn some, or maybe has some programming experience, but is not a super expert, and it would appreciate an API that already kind of simplifies a lot of the programming tasks. And we also have the seasoned developer, the guy that is a Python expert, suddenly gets hired and say, hey, you're going to do this automation for network, okay? That person will also appreciate having an SDK that is well documented, but that person for sure will need assistance from an SME because both of those people do not have to learn Yang, but they need to somehow become familiar with the hierarchy. The data is the data, and the data is important. You need to understand that interface has a name, that you have a description, that you have an MTU. But that's very different from if I give you the raw data model, you have to learn the syntax. Yang has a syntax, and you have to learn a lot of stuff.
Yeah.
All that just completely disappears for both of those personas. You don't need to learn Yang as a language. Yes, you need to become familiar with this hierarchy. Yes.
Okay.
All right. So what are some of the, let me just make one last point and we'll move to the next slide. So as I said, the SDK gives you the models and objects, so you can instantiate objects against configuration or counters on the device. But something that is unique about this SDK is that also allows you to communicate, create clients that communicate with the device. So the library itself has support for netconf. We added support for RESTconf. We also added support for Open Daylight. So I can create these objects in a very simple fashion in my client. I can specify this interface configuration that I created. I want to send it to this box via RESTconf or via netconf. And I can do that without manipulating XML directly or manipulating JSON or having to learn all the RPCs in netconf. All that stuff is completely hidden away from me, okay? And that level of abstraction is key to accelerate automation, whether, again, you're the seasoned developer or whether you're the network engineer that suddenly is having to do some automation. All right? So that's basically the 2 points that I wanted to touch on the model-driven manageability. Again, we talk about doing automation, interacting through the management plane. We talk about how all the data models are important, Yang being the language that is used, and we talk about the SDK that we provide to customers. So now Akshat is going to cover the second piece, how to do automation in which you actually bypass all this infrastructure of the management plane and you go to a lower service adaptation layer on the device where you have closer control of the device and you get a much higher performance, okay? Akshat?
All right, thanks, Santiago.
So can I ask a question?
Yes. Oh, any questions?
It's just to give me, I think, the picture. So you got a dev that's writing the code that interacts with the network. You got a networking SME that's telling the dev what needs to be done for networking to work. And at the end of the day, who's using this product that the dev is making?
Usually the NetOps guys, whoever is operationalizing the network.
Operation.
Well, we're talking about SP-WAN here, right?
Yeah.
So in service providers, you've got a whole different audience, I think.
It's someone who's sitting in a cubicle that's got an order for something, and they're click, 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 and go.
Yeah.
So it tends to be slightly different, at least with a lot of the customers we work on the service provider side. The lines are pretty much blurring between developers and network engineers. You don't have like someone who only knows networking and someone who only knows how to code. There are really good developers in the networking community within the service provider domain. And frankly, a lot of the requests and the API infrastructure requests that come from them are the ones that define how we build these out. Right? So the focus on Yang, the focus on OpenConfig, the focus on model-driven APIs is really a function of how a lot of these sophisticated customers in the service provider domain have sort of gone over the edge of not just being a network engineer, but now being developers as well. So they develop the tools that will help them operationalize their network. Right? So the lines are pretty much blurring there.
Yeah.